9-4. Yesterday, we started with some formulas. We did an in-class activity, and it helped us discover some formulas. These formulas only work if we rotate around what? 0, 0, which we call the origin. So if you were gone, watch that video. It's only about 10-15 minutes, I think. We came up with some formulas. They're on the board over there. They will be there for a quiz. You can use these if you're rotating about the origin. So when we did number 1, we didn't use any patty paper. We wrote down our points. We applied the formula, and we got our new points. When you rotate around the 0.51, you can't use those formulas. So what you do is you take your patty paper, you trace those points, write them down, cut it out, and rotate it. It's counterclock. So the clock moves this way. So counterclock is this way. So this whole figure is going counterclockwise 90 degrees. It's very helpful if you have the patty paper to actually spin it around that point. We did number 3, rotating around 2, 2. That's not the origin, no formulas. Cut this out, spin it around that point. Number 4 we did. About the origin, so again, write the 4 points, apply the formula, that will give you your new points. Here's where we're starting today. Number 5, write the rotation that maps A to B. Essentially, we are writing one of those. So let's start with capital R. If you do a lowercase, that's usually reflect, but I don't take off if it's uppercase or lowercase. Now, we have to figure out what point. What you want to look for, yeah? Oh, you're going to tell me. What you want to look for is a point possibly that did not move. Does anybody see a point on A that did not move? What is it?
1, 0.
Yeah, right here. That is the point of rotation because it didn't move. Now we have to say, this is what we want to rotate around, but how many degrees? What do you guys think we should do? How many degrees?
90.
90 which way?
Right.
Clock. We have to go A to B, so A has to fall down to B. That's the way the clock moves. I would accept another answer. Does anybody remember a different way I could say 90 degrees clockwise?
Right.
Yeah, I could go 270 the other direction. We talked about that yesterday. Number 6. Is there a point on A that did not move? No, the whole figure moved. So how do we do it then? I usually draw a line straight through my figure. I'm able to draw a perpendicular line just like that, straight through my other figure. Does that help you figure out what point it is? Yes, the point where they intersect. So that looks like the point over 1, down 2. Okay? Do we want to go clock or counterclock? Which one? How many degrees? 90. It will always be 90, 180, 270. I'm never going to ask you to rotate like 30 degrees or 40 degrees because it's really hard to calculate that. So if I'm asking you, it's going to be an exact 90, 180, or 270. Number 7, perform the following transformations. So I will pass out the patty paper. Some people have found they just like to trace it. They don't really need to cut it out, but you can. So I'll pass out patty paper. And if you want scissors, take those also. Usually the people who use scissors and patty paper make less mistakes. Take them if you want them, if not, just pass them back. So the only Spanish I know. Oh, actually, question. So how do you say red in Spanish? Rojo?
Oh. I don't even
Does
know.
anybody know red in French? I believe it's French.
Yeah.
So rojo, that's correct? All right. So what we are doing here is we are rotating around point C. So let's put a big dot at point C. Let's trace your triangle. And then see how you do. Trace it, cut it, and then rotate it the way the clock moves. Draw your new one. You can actually put your pencil on the patty paper at C so it doesn't move and spin it around. Would like everybody to get it before I put the answer down. This is Matthew. So just fix that. And just spin it and see. That's close. That's probably not. I'm going to put a little A in there to signify that that is the answer to that one. I saw many of you had that. Good job. Mine did get a little bit bigger. My triangle shouldn't be quite so tall, but it's pretty close. Okay, our next one. Rotate about the point O, 180 degrees. You'll notice it doesn't have a degree. It really doesn't matter for 180 because it's the same both directions. However, you might want to make a note. If it doesn't list the direction, no direction is listed, assume counterclock. That's a rule of thumb. You might need that for a quiz. 180, it doesn't matter. But if it says something else like 90 and no direction, clock or counter, it's always assumed to be counterclock.
Oh. Those were not for me.
This one is a nice visual if you want to look up here. I couldn't really do the others with this technology, but I can rotate around 0.0. So it's going to look like this. 180. So here's 90. I guess if I'm going counterclock, 90, 180. Notice where my points are. B was on the left. Now B is on the right. Call it B double prime, C double prime, and this is part B. We do need to discuss C because there's a negative 90 there. Let me write this one a little bit bigger. It doesn't have a direction. If there's no direction, it's going to be counterclock, so you can add that. Now, what does the negative do? The negative just means go the other way. So actually, it says negative 90 counterclock, but because it's negative, that's actually just 90 the other direction. Try to rotate around point B, 90 degrees clockwise. No direction means counterclock. Okay, here is C. I'm rotating around point B. 90 degrees the way the clock moves, so that's going to turn out to be like this. Any questions on this? Okay, our last section is identify the degree of rotational symmetry. This is not lines of symmetry, not lines of reflection. This is degree of rotational symmetry. So please look up here. I'm going to show you actually with this last one. You don't actually need patty paper, but you could. Might be helpful to some. Please watch what I'm going to do up here. The question is, how many degrees can I rotate it to where it looks like it started or it's on top of itself? So if I rotate it like this, that doesn't look good because the vertices are all mixed up. If I keep rotating, see how nicely that lines up? And then it happens again and again and again and again, so many times. The question here is, identify the degree. So how many degrees do I have to rotate it? Right there. I heard 40, I heard 90. We have to have exact, so we need a systematic way to figure this out. It's not any of those guesses. Good try. Good try. Yeah. Good try. Yeah. So we're not just going to eyeball. There's a mathematical way to get the exact number. Oh, that was excellent. Who said that? Yes. So take a look again. If I go all the way around, that's 360 degrees. Notice I go 1, 2, 3, 4, 5, 6 equal distances make up the full circle. So if all the way around is 360, and I went to 6 equal spots where it lined up, just divide by 6. What do you get? 60 degrees. Now, some people say, oh, it has 6 sides, so it's always going to be 6. That's not true. It has 6 lines of symmetry, so divide by 6. That's not always true. Let's look at this next one. Okay, watch as I rotate it. Not good. Is this good? Not good, not good. That works. So that's 1, 2, 360. For the full circle, there were 2 times at which it overlapped, so 180 degrees. I didn't divide by 4 because it has 4 sides. It has nothing to do with the number of sides. Try A and B on your own. You can just eyeball it, or you could trace it with patty paper and actually spin it. You shouldn't need to cut it out. I think I saw some hand up back here. Go get a calculator. Lazy. Are they the same because they're both triangles? Nope. What do you guys have for A? What do you think? It really doesn't. So you can do 360 just the one time it overlaps itself, which is just 360. Some call this no rotational symmetry. You could say 360, I'll take that. Or you could say it doesn't have rotational symmetry. There's no other degrees to which it rotates on top of itself. Please look at A again. Do you guys see this has a line of symmetry? Just because it has a line of symmetry doesn't mean I can rotate it 180 degrees or halfway. That's a common misconception. What'd you guys put for B? Yeah, 360. It will fall on top of itself 3 equal times, so that's 120 degrees.